Hi, this is Nataraj Ponna and I'm going to do a term paper presentation on athletics injury data analysis. Here is the overview. We are going to state the business objective, the crisp 3 steps of data understanding, data preparation, modeling, and evaluation, and then do some reporting analytics and state business recommendations and future scope of this project. The basic business objective here is to analyze the characteristics of athletes' injury dataset and draw some valuable insights to improve the overall team performance and also to suggest steps to manage the injuries by helping the coaching staff and medical staff in making better decisions for the players who are getting injured. The data here was pre-collected and organized as per type of sport, which was again categorized into injury-specific variables like body part, site, laterality, action taken, severity, and player-specific variables like player ID, position played, etc. The dataset contains a total of 1051 records belonging to 11 categories of sports, out of which a majority of 560 records belong to football. The injury data here again is divided into team-specific and out-of-team related injuries. In preparing the data, I removed the offset spaces from the beginning and the trailing ends. I manually corrected the data errors where entries of many columns crept into other column. I computed an additional column called as healing time period and classified it into various classes. I filtered the data specific to football and restricted entries only to the team-related injuries so that a reasonable model can be built. I removed the columns with majority of null values like weather condition, temperature, and actual temperature. I imputed values for columns like activity and injury occurred during. Here is the snapshot of the data. It contains the position of the player, the injury date and close date, which are used for healing categorization, the action taken, the injury, the body part, body site, laterality of the injury, the current status and severity of the injury, and other variables like event location, field type, and activity. I built a classification model for injury healing time using IBM SPSS modeler. The injury healing time here is divided into 6 classes, less than or equal to 1 month, 1 to 2 months, 2 to 4 months, so on. Here I made up 384 records which belong to football specific injuries. Here each injury record is considered as a separate record, even if a player has multiple records, since the injury healing time is different for different player and the injury start date and end date are different for different injuries. There was hardly any overlap that was seen between the injury records. So this is the basic assumption of the model. I used a multi-layer perceptron neural network with one hidden layer to do the classification. Here is the model evaluation. The overall accuracy is 71.9%, and from the predictor variable importance, we see that the current status, severity, and injury are the most important predictor variables. From the classification summary, we see that the overall percent correct is 79.5%. I tried several other models like C5 Shade, but they predicted the classes by taking only severity as a most important predictor and rest all predictor variables were not used, so the results were biased. I also did a sequence analysis based on the time field of injury healing duration. I used SPSS modeler here again, and I took the player ID as the ID field and the content fields as body part and injury. From the evaluation, we see that for the body parts alone, if a player has injury on femur, then he's most likely to have injury on foot and knee. If a player has had an injury on shoulder, then he's more likely to get another injury on a knee. And coming to the injury, for the players who had strain are more likely to suffer sprain, and the players who had contusion are more likely to suffer sprain. Now comes the interesting part where we combine both body part and injury. So for a person who has had an injury on femur and it was a strain, then he is most likely to have another injury on femur. If a person had had an ankle strain, then he would suffer a sprain in future. But when we look at the support and confidence percentiles here, they are pretty low because we contain only 384 item sets. I use Tableau to build some visualizations. Here's the first one. It categorizes each sport related injuries according to the healing categorization. So we see that the football is standing out because it has got lots of records, and the majority of injuries got healed in less than or equal to 1 month duration. In this visualization, we see the healing categorization versus the action taken for the injury. We see the light blue colored bar, which is the treatment done by training room staff, getting extended into 1 to 2 months, 2 to 4 months, and 4 to 6 months as well. This indicates that the treatment done by training room staff is not adequate. This visualization shows the non-sport related injuries categorization. Now, this is important for the coach to identify the players who are getting injured outside the game, and he might instill some discipline in them. This visualization talks about the injuries that are occurred during conditioning, game match, practice, sanction training, etc. It also brings in the field type on which the players were playing. So during the practice, it is observed that majority of injuries have occurred on the grass field type. This visualization shows the injuries that occurred at various football positions and also the field type on which the game was played. Now we see that majority of injuries occur at defense secondary, wide receiver, linebacker, and offensive line positions. And out of all of these, a majority of injuries occur on artificial turf. This visualization brings in the healing categorization of injuries that occur at various football positions. We see that the healing categorization of the injuries of 1 to 2 months occur at across almost across all positions that the players play. But specifically, the injuries that take 2 to 4 months and 6 months to 1 year occur only at positions of cornerback, defensive secondary, defensive line, and wide receiver. Coming to the business recommendations, we can use this classification model to predict the injury healing classes for the players who are getting injured even before the treatment is done. So the coach can make the informed decisions on having backup plans to replace the players. Using the sequence analysis, the coach can better train the athletes to take precautionary measures during the game to avoid future forecasted injuries. Decisions about whether or not to have training staff oversee the player injuries can be further thought about. The players getting injured in the non-game related events can be identified and discipline can be installed in them. Since there are more number of injuries on artificial turfs, the players can be further trained to avoid injuries on artificial turf. Wide receiver, defensive, secondary, linebacker, and offensive line players have got higher injuries and greater healing time. So treatment offered to them should be looked upon. They should probably be sent to trained physicians and hospitals instead of having the training staff give them the treatment. I see that this project is interesting and there is a lot of future scope for this project. If the data set is made more comprehensive, then the prediction of classification and generation of association rules can further be improved. Several other sports can be modeled similar to what we did for football. Some of the variables can be used as prediction criteria like close date of injury, field type, weather condition, temperature condition, the actual temperature, onset and activity. If they are populated with right values, they can impact the generated classification, and furthermore, modeling can be done to predict the injury itself. With sufficient data, the present model can be further broken to predict the week-wise healing duration for better classification during the game seasons. Because even if a player is getting injured for greater than 2 weeks or 3 weeks, it can impact the game as a whole. There can also be prediction done to predict the scale of severity of the injuries. I thank you all for looking at the presentation.